Hi everybody. In this video, I'm going to be going through the notes for lesson 8.9, which is going to be a little bit of a change of pace. Up until now, in all of these review videos, we've always been talking about solving equations. What we're going to switch gears to right now is to talk about graphing equations of lines. And the first part of understanding how to graph an equation means we need to understand slope. So let's talk about slope. Slope is the pattern of a linear function. So slope is only for lines. This is very important. Curvy graphs don't have slopes. When we talk about slope, we always use the letter M for slope. In math, we use the letter M because slope is a pattern. It tells us how to move. So I always remember we use the letter M because the slope tells us how to move between the points on a graph. There are 4 different types of slopes, and you're going to need to be able to look at a graph and know which of these slopes you're looking at. Slope type number 1 is what's called a positive slope. A positive slope is a slope that's going to be going uphill when you go from left to right on your graph. Whenever you look at a graph, you always read the graph going from the left and moving to the right. Now, a negative slope is going to be a slope that is going downhill when you read a graph going from the left to the right. Whenever you read a graph, you always start from the left side and go to the right side. A zero slope is a line that is zero fun. It's completely flat. There's no cool things going on with this line at all. A zero slope is going to be completely flat, and an undefined slope is going to be completely vertical. Sometimes we think about this as being a horizontal line. If your line is horizontal, it has zero slope. And undefined is always what we use for a vertical line. I like to think about that as if you tried to ski on this slope, you would not exist because you would be a pancake at the bottom of the hill. So we say that you're undefined if you try to ski on that slope. Let's talk today about how to find slope from a graph. So we are going to be able to find slopes without graphs, but today we're going to focus on slope specifically when you look at a graph. Let's go over the rules. First, you're going to find 2 nice points. Now, sometimes I'm going to be nice and actually put dots on your graph paper where there are nice points. Sometimes you're going to see lines that don't already have pre-drawn in points. You can always draw in your own. The thing is, you want to look for points that cross at the corners of the grid that's on the grid paper. Then the second step for finding slope is that you start from the left. So wherever the left point is, you always start there and you move to the right. And then we're going to make a slope fraction. Now this is going to be really important. Slope is always a fraction. Here's how we make our fraction. Now, a fraction has 2 numbers, a top number and a bottom number. The top number of your slope is what we call the rise. It tells us whether we need to go up, so we have a positive number, or down, so we have a negative number when we're walking from one of these points to the other point. The bottom number of our slope is what is called the run. Now remember, we're starting from the left side of the graph, so our run is always going to be to the right, which means our bottom number is always going to be positive. Let me show you what I mean. I'm going to zoom in really close on this graph, and I'm going to erase some of my highlighting just so you can see what I'm doing. Remember, we're starting from the left point. So let's just review. We're starting from here. We want to walk to here. So if I start from down here, the first thing I'm going to do is ask myself, do I need to go up to get to the second point or down? The answer is I need to go up. Now I have to follow the grid lines. I can't go diagonally across the graph paper. I have to follow these lines on the grid. So if I want to go from this point to this one, I need to go up 1, 2, 3 levels. So we say that our rise is 3. Then we look at our run. Our run is how many spaces do we need to go sideways. In this case, we need to go sideways 1, 2, 3, 4, 5, 6 spaces. So our slope fraction would be the rise, which is 3, divided by the run, which is 6. Now, the last thing we always need to do is reduce. Reducing means simplifying this fraction. On your calculator, you're going to hit alpha, which is the green button. Then you're going to hit y equals, which is in the upper right-hand corner of the screen. And if you hit enter, it's going to let you type in a fraction. You're going to type in your slope fraction, and when you hit enter again, the calculator should simplify it for you. In this case, the calculator should tell you that the simplified slope is 1/2. All right, let's practice finding some slopes. Now I'm going to keep my screen kind of zoomed in on some of these graphs. For problem number 1 here, we want to find the slope. So we're going to find some nice points on the graph paper. Now in this case, I didn't give you any nice points that I already labeled for you, so you're going to have to find some. I'm going to look for places where this line crosses the grid that's in the background perfectly at the corner of a box. So one spot would be here, and another spot would be here. A lot of the other places on this line get close to the corner of a box, but it's not perfect. Now remember, we always start from the left side of the graph. So I'm going to start from the higher point this time. It doesn't matter whether the left is the higher or the lower. It just matters that it's the left. Then I'm going to do my rise, which might be going up or it might be going down, divided by my run, which is always going to be going to the right. So let's see if we can make a slope fraction. Starting from the higher point, because that's what's on the left, I'm going to go down until I get to the same level as the second point. And then I'm going to ask myself, how many spaces did I need to go in a downwards direction? It looks like there are 4 jumps here. So I'm going to write -4 because I went in a downwards direction on the top of my fraction. On the bottom of my fraction, I need to slide to the right until I land on top of the second point. And then I'm going to ask myself, how many spaces is that? If I count those spaces, it's 5 spaces. And then I'm going to enter this fraction on my calculator. Now again, you're going to hit alpha, y equals, and then type in the fraction, and it should simplify. And in this case, it just tells you the same answer you've already got, which means this fraction actually doesn't simplify, and you're actually done. Let's look at another example. Problem number 2 is another example where I pre-labeled on the graph for you some nice points. Remember, in our slope fraction, our rise goes on the top, and it might be positive or it might be negative. And our run goes on the bottom, and run is always to the right, and it's always positive. So let's find our nice points. We're always going to start on the left. In this problem, the left side is the lower point on this graph. Then we're going to walk to the other point, which means in this graph, we're going to have to go up 2 spaces. But here's the catch. On this graph, each space is actually worth 3. So if you count 3 plus another 3, this is worth 6. Then I need to go to the right. It's 2 spaces, but on this graph, we count by 2s, 4, 6, 8. So 2, 4 spaces. That means that we get 6 up, and it's positive because we're going up, 4 to the right, and it's counting by 2s, it's counting by 3s. That's why it's only 2 spaces or 3 spaces. And then we're going to type this into our calculator, and we're going to get 3 over 2. Now, let's practice graphing a slope. Sometimes I'm going to give you a slope, and I'm going to say, please graph the slope. So put some more points on this graph by following this slope pattern. Now remember, m is always the letter for slope, and slope should always be a fraction. So if you ever see a problem like this where it's not a fraction, we're going to fix that by putting a 1 on the bottom. We only need to do that when the number that we're given is not already a fraction. Now the top number here is the rise, and since it's positive, we're going to go up 3 spaces. The bottom number here is the run, and the run is always to the right. You never run left. So let's count. Let's start from this dot and rise 3 spaces. Then let's run to the right 1 space and put another point on the graph wherever we land. Now we can follow that pattern but go backwards. So go left 1 space and then go down 1, 2, 3. Hopefully you see that these are mirrors of each other. We're just following the pattern in a different direction. Let's do it again. Go left instead of right, and then go down instead of up. We're just reversing ourselves. What you should also notice is that all of these points that we just drew end up in a straight line, which is really important. We want to make sure that all of our points end up in a straight line because we want to make sure that we're following a slope pattern, which only applies to linear functions, lines. Let's try another one. In the next problem, it says graph the slope, but this time it actually is a fraction, which is great. So how are we going to graph this slope? Well, the first thing that's kind of weird is that this negative is at the beginning of the slope fraction instead of on the top or on the bottom. The rule is that negatives always belong to the top. Remember, the bottom number, the run, is always positive. So I'm going to rewrite this as -2 over 3. Now the top number is my rise. That means we're going to go down 2 spaces instead of up because it's negative. The bottom number is my run, and we're always going to run to the right. We never run to the left. So starting from this point, I'm going to go down 1, 2, and then I'm going to run to the right 3. Now I know the graph is a little bit too small here. Let's just pretend that it keeps going. And we end up with a point over here. We could repeat that. We could go down 1, 2 more, and then go 1, 2, 3. Again, you'll notice that all of these points end up in a straight line, which is good because the whole point of this is that we're graphing slopes, which only work for linear functions. All right, thank you guys so much for watching. Please try the practice problems, and I will see you soon for the next notes.